Hello everyone. Today we're going to have a bit of a talk about depreciation in buildings. Now, we don't often think about buildings depreciating. We often think about cars depreciating, but we don't often think about buildings depreciating. But in fact, buildings do depreciate during their life. During their life they will depreciate to a point eventually where the added value of the buildings to the land will be nil, and under those circumstances the building will be ripe for replacement. Depreciation will take several different forms. It can take the form of being physical deterioration, it can take the form of functional obsolescence, and it can take the form of economic obsolescence. The most important time when we're going to be looking at depreciation is when we're looking at our summation valuation methodology, or also known as the cost approach for valuation. Where we're doing a summation or a cost approach method, they're the same thing, we need to be able to take into consideration the depreciation which a building has suffered. So a building will suffer depreciation simply because of its age or any of the other factors. If you stop and think, and you think about, I have a choice between buying a brand new house on a block of land or buying an identical house next door on an identically sized and so on land, one house is brand new and one house is, I don't know, maybe 10 years old. Which would you prefer to purchase for the same amount of money? And most people will say, well, I would want to buy the brand new house because the 10-year-old house has got scuff marks in the paint, and the wiring is 10 years old, given the wiring doesn't last forever, and so on. So if the whole market thinks the same way, then by definition there is a depreciation factor to be taken into consideration. The depreciation is made up of the three functions that I mentioned before, and that was physical deterioration, functional obsolescence, and economic obsolescence. So let's have a look at those three. The first one was physical deterioration. Physical deterioration is the deterioration of the building physically. It's where the dry rot gets into the building carpet is being walked on all the time and that wears, the paint gets knocked around a little bit, and so on. So all of that comprises physical wear and tear on a building. That component is unavoidable, but it is also repairable. Where you have a building where physical wear and tear is being rectified, so the house is being painted, plumbing is being replaced, and so on, then the actual rate of depreciation slows or even goes backwards at that particular point in terms of the overall value of the property. Physical wear and tear does not equally affect all components of a house. It depends on the residual life of the building or the residual life of the component. So the building itself has a real life which could approximate 100 years, but other components of the building will not last anything like that length of time. For example, the electrical system of a house normally has to be rewired every 30, maybe 40 years. So it will have its own rate of depreciation within a house. Same with the plumbing. The plumbing, particularly if it's a galvanised iron plumbing system, might only have a life of 20 years or so. The PVC system appears to have a life in excess of 20 to 40 years, but again we still haven't seen the full extent of that. Gas lines will have another rate of depreciation, and so on. So all of that needs to be taken into consideration by the valuer when they're looking at the physical deterioration of the building. The next is the functional obsolescence of the building. Now, the functional obsolescence of the building is different from the physical wear and tear. The functional obsolescence of the building relates to how the building is actually being used today and what technologies are likely to be replacing it. So things such as obsolescent plant and equipment like lifts, for example, become functional obsolescence. Things such as the layout of the building can mean that a building which is quite fine for when it was constructed becomes functionally obsolete because the layout no longer suits modern uses. Building technology becomes quite important when we start looking at functional obsolescence, and building technology is changing very rapidly. You might not think so, but the way that the technology of buildings has progressed, even in the last 20 years, has been quite outstanding, and means that a building, particularly commercial building, industrial building, retail building, of 50 years of age or older, may well be totally inefficient in relation to current technology requirements. So, for example, if you have a look at a lot of the big box bulky goods retail uses, such as the Bunnings and the Masters and the Officeworks and places like that, a lot of those buildings have clear span space and high clearance. 50 years ago, none of that could have been constructed. So none of those uses would want to be in a building with an age of 50 years, for example. So 50 years ago, the building technologies might have been that ceiling heights were maybe 2.4 or 2.8 metres height, lots of columns throughout, particularly industrial, office space, commercial, retail, timber floors, firefighting equipment would be substandard in relation to standards of today, but were satisfactory as at the date of their construction. But it means that buildings which are in an area of construction where technology is moving means that those buildings that have been constructed become functionally obsolete very quickly. The final one is economic obsolescence. Now, economic obsolescence is about obsolescence which is extraneous to the owner's capacity to do anything about. Under these sorts of circumstances, you see things such as non-conforming uses, for example, where town planning requirements, zoning and so on, change, and a building goes from being a complying use to being a non-complying use. Such changes as that will increase the economic obsolescence of the building very quickly. It's where the highest and best use of the building is being impacted because of factors outside of the owner's capacity to change them. Specialised use buildings in particular are very vulnerable to economic obsolescence. A lot of the squash courts of the 1970s, squash court buildings of the 1970s, were purpose-built buildings which were highly useful at the time, great highest and best use at the time of their construction, but today far fewer people play squash. So therefore, a lot of those special use buildings need to be converted to other uses, and that means that as an existing building, they have suffered significant economic obsolescence, and the only way to try to keep the building at a level of highest and best use, which is economic, is to go through and do a refit out process, or even to demolish the whole thing, in which case the value of the building, even though it's physically quite satisfactory, still functionally quite the layout is still quite functionally useful for its original purpose, means that the building has very little value, or significantly reduced value, simply because of its economic obsolescence. This economic obsolescence can also occur where land values are high, and therefore building values in relation to the land tend to fall very quickly, so that they can be demolished. So, for example, you might have a look at the Sydney Entertainment Centre, which was built in the 1980s. It's been demolished. It's just a dust pile now, simply because of the rising land value of the site that the building was constructed on. So within 30 years or so, the building has gone from being a fully new value to having no value at all. This can also happen in areas of gentrification or where there's a lot of redevelopment going on. The way that depreciation in general, incorporating our physical depreciation, functional obsolescence and our economic obsolescence works, is that it works off a reduction in the value or in the cost to construct new as at today's date, and that is increasing at a rate which is different from CPI. So the construction rate, materials and buildings, is tending to increase at, I don't know, maybe 6% per annum, where CPI may be approximating 3% per annum. So don't get caught in the trap where you believe that building costs are increasing at a CPI rate. They are increasing at their own rate of increase. Depreciation is always then subtracted off the cost to construct new as at today's date, not when the building was built. We don't care if an 1880s or an 1890s Victorian terrace was constructed for the princely sum of £1,100 or $2,200 in today's dollars. We're only concerned about what would it cost to replace that property or that improvement with a new improvement at today's construction costs. Therefore, depreciation is always taken off the current cost to construct new today. Okay, well, I hope you've got something out of today. Thank you for watching.